payload is defined as the difference between the mass of displaced air and the mass of balloon. What is all this nonsense? Actually, what they're referring to is a hot air balloon, or in general a balloon. If you have a balloon like this, fine. And if you're trying to hang a bucket, if you're trying to ride the bucket and go up in the air with the balloon, they're trying to give you some idea about payload. We will talk about that. What is payload? See, when a balloon is floating up in the air, any spaceship, any aeroplane, whatever, they have a mass of their own, right? So a balloon must fly itself. A balloon has a mass of its own, indeed. Whatever extra weight it can carry, that is called payload. I mean, one thing is, I'm carrying, see, if I climb, say, a mountain, I'm climbing myself. That's fine. I have to carry my own weight. If I'm carrying some extra weight, then that extra weight will be called the payload. They are giving you some kind of a feel, how can you calculate payload? We can do that. We don't need the gyan. Let's read the other part. Calculate the payload when a balloon of radius 10 meter. Now, we have radius of balloon is 10 meters. So it seems like a spherical balloon. Mass of balloon is 100 kg. Quite tremendous. Is filled with helium. Now this is helium. Pressure is 1.66 bar. Temperature is 27 degrees Celsius. That is 300 Kelvin. Density of air I am given is 1.2 kg per meter cube. Fine. Now, in general, if a balloon is just able to float, can I do a simple force balance? Yes. And what would that force balance say? That upward force is the buoyant force and the downward force is mg. And a limiting case, upward force has to be equal to downward force. Now, what is pulling down? Mass of balloon plus mass of helium plus payload. This is the mass which is pointing into gravity. This was pointing downwards. What is upward? I recall Archimedes' principle. It says that whenever a substance is immersed in a fluid completely or partially, it experiences an upward force, and the force is equal to, magnitude of force is equal to what? It is equal to the mass of fluid displaced by the immersed part of the body. So this is equal to mass of air displaced. All this must be equal to this, right? And mass of air displaced must be equal to density of air into volume of air displaced. But how much of air has been displaced? Same as volume of balloon. Density of air into volume of balloon. Let us say payload is some number P. How much is mass of helium? Mass is moles multiplied by molar mass. Moles of helium into molar mass of helium, which is 4. Mass of balloon is given to me. Of course, force is this much into gravity. Gravity will cancel away. So we don't need that in next step. Plus mass of balloon. Mass of balloon plus payload. They stay where they are. N is PV by RT. This is pressure of helium into volume of helium by RT into molar mass of helium. This is so much. Can I calculate payload? Yeah. Payload P will be equal to all this dirt. Now volume of helium and volume of balloon are the same. So volume of balloon becomes common. This is density of air minus all this goes on that side. What is this? Pressure of helium into molar mass of helium by RT. Actually, this is nothing but density of helium. Fine. Minus mass of balloon. I have got a formula for payload, right? Difference between the mass of, this is mass of displaced air and mass of balloon, right? Can I substitute? Well, this is all I can do, so let us do that. How much would that be? Let's calculate. Volume of balloon, which is 4/3 pi r cube. So payload will be 4/3 pi r cube. R is radius, which is 10 meter. This will be volume in meter cube, please remember. Now, if you want to convert this to decimeter, please remember 1 meter is equal to 10 decimeter. So, if you are interested in changing units, one could also change this unit. Instead of 10 meter, I can write how many decimeters? I can write 100 decimeters. This becomes easier. So, this is volume of balloon. What do I have? I have density of air, which is 1.2 kg per meter cube, minus this thing. So I have 1.2 kg per meter cube. No, this is dangerous because units are in meter cube here. Never mind. Minus the helium stuff. What is that? Molar mass of helium is 4 grams per mole. Pressure of helium is 1.66 bar. Divided by RT, R is 0.083 bar decimeter cube per mole Kelvin into temperature is 300 Kelvin. Minus mass of balloon, which is 100 kg. Let it continue. Let's watch the fun. First of all, be careful about the units because this seems to be having mixed units. Bar cancels away with bar, mole with mole, Kelvin with Kelvin. So I'm going to obtain something in grams per decimeter cube here, it looks like. This is 1.2 kg per meter cube. Fine. Minus 1.66 into 4 upon 0.083 into 300 grams per decimeter cube. Now 1 gram is 10 to the minus 3 kg, or decimeter cube is 10 to the minus 3 meter cube. So grams per decimeter cube is same as kg per meter cube. There is no difference. So they have same units. All I need to do is to multiply this and calculate this. तो आपको बस इसी को आगे सॉल्व करना है. 4/3 पाई 22/7 इंटू डेसीमीटर की जरूरत नहीं है, केजी पर मीटर क्यूब में काम चलाएंगे, बढ़िया है ना. तो 10 मीटर्स इस पूरी 4/3 पाई आर क्यूब, ये इतना ही है ना, ऐसा. ठीक, तो ये आ गया वॉल्यूम मीटर क्यूब में. ग्राम्स पर डेसीमीटर क्यूब को हम केजी पर मीटर क्यूब भी लिख सकते हैं मजे से, -100 kg ऐसा आ जाता है. यूनिट्स बड़ी कंसिस्टेंट है. मीटर क्यूब यहाँ पे कट जाएगा, ये आ जाएगा मास ऑफ एयर डिस्प्लेस्ड इन किलोग्राम्स -100 kg. ये आ गया पेलोड, अच्छा खासा पेलोड है 3811 3811.1 kg. इतना सामान लाद सकते हैं जो बलून ढो के ऊपर ले जाएगा, अगर आप ये सब करने में समर्थ हैं